next topic we're going to cover is exponential rules. I've always really liked working with exponents, so I'm excited to make these videos. I haven't made any videos over exponents before, so I think this will be really useful. So the first thing I want to talk about is what an exponent is. So an exponent is a whole number that indicates how many times a base number is to be used as a factor. What does that mean? So what I'm saying, and I have 8 cubed, or 8 to the third, we say that cubed. That means I want to take 8 multiplied by itself 3 times, okay? And this is standard notation, again, just to make things a little simpler. And you might say, oh, okay, 8 to the third, that's not too bad to write, but what if you had 10 to the 15th, or 7 to the 23rd? Now, not only would these be really, really big numbers and take forever to write out, it also would be really hard to have to write this out instead of using this fancy exponential notation. See? Told you mathematicians were lazy. So, we have 9 squared, right? That comes from the area of a square. If I have a square and its area and its one of its sides lengths is 9, right? Its area is going to be 18. So, wow, no, 81. Oh my gosh. So its area would be 81, which is 9 squared, right? If I was going to have a cube, let's say it was a cube that was a 2 by 2 cube. As you can tell, I'm not an artist, right? The cubed part comes from the volume of a cube. Because to find the volume of this, I would take 2 times 2 times 2. When I raise something to the first power, it's just itself. 3 to the 4th power is how we say anything bigger than 3 be 3 to the 4th, 3 to the 5th, 3 to the 6th power. I can also take things to the 0 power, and we're going to go over how that is always going to be 1 unless it's 0, which is undefined. Oh, we're going to do it on the next slide. So any number other than 0 raised to the power 0 is 1, okay? And that's anything raised to the power of 1 is just itself. That's like saying, okay, I'm going to take a multiplied by itself 1 time. Well, that's really just a. So let's go ahead. If I have 6 to the 0, that's 1. If I have 5 to the 0, that's 1. Plus 12 to the 0, which is 1. I could also distribute this 0, and I would get 1. But up here, 1 plus 1 is 2. So the first rule of exponents is the product rule, right? And that says if I have any real number a as my base and it's multiplied by another exponent of the same base, what I can do is add those exponents. Okay, why does this work? Let's say I had 2 cubed times 2 squared. Well, 2 cubed means I have 3 2's, and 2 squared means I have 2 2's. So how many 2's do I have now? I've got 1, 2, 3, 4, 5. Well, wouldn't that just have been 3 plus 2? So it's a simpler way for us to figure that out. So here I've got 5 cubed times 5 to the first. That would be 5 to the 3 plus 1, which is 5 to the 4th. Here I've got x to the 8th times x to the 7th. X to the 8 times x to the 8 plus 7, that gives me x to the 15th. If I have 3 to the 4th times 3 cubed times 3, that's 3 to the 4 plus 3. And what's the exponent here? Well, that's going to be a 1. That gives me 3 to the 8th. If I'm multiplying them together and they have a coefficient in front, I need to multiply those coefficients. So I've got 2 times negative 4, which is negative 8. Then I can go ahead and add those exponents, y to the 3 plus 4. So I have negative 8, y to the 7ths. When working with negative exponents, if I have a negative exponent, that actually is a fraction and that goes down into the denominator. So if I have 4 to the negative 3, that's going to be 1 over 4 cubed. If I have 3x to the negative 3, it's important to remember that the parentheses mean this negative 3 is attached to the 3 and the x. So that'd be 1 over 3x cubed. If I just have 3x to the negative 3, it's important to know that that negative exponent is only attached to the x, right? There's no parentheses. So I've got 3 times 1 over x cubed, which simplifies to 3 over x cubed. Now, what do I do if I have a 1 where the negative is in the denominator? I'm going to go ahead and change color for that to make it more clear. Well, if it's a negative, right, I should be rewriting it as a fraction. So let's take a look at that. If I have 1 over 4 to the negative 3, that's 1 over 4 cubed. Remember, this is called a complex fraction. When I'm dividing fractions, I keep the first fraction the same. I change from division to multiplication, and I flip the second fraction. So that gives me 4 cubed. So it just goes into the numerator. So in this case, if I have 5 to the negative 3, I know that's going to go to the denominator. But I have 2 to the negative 5, sorry, that becomes a positive, in my denominator. So that's going to move to the numerator and become positive. Our quotient rule states if I have any two exponents to the same base, I subtract the exponent on the denominator from the exponent in the numerator. So let's see why this works. Let's say I had 2 to the 4th over 2 squared. Well, I know that these two 2's are going to cancel, and so are these. So I'm left with 2 squared. Well, that's the same as 4 minus 2. So if I have a to the m over a to the n, and I have to subtract exponents, remember, even though we're working with variables, these variables represent numbers, so we can do everything we could do with a variable. I've got a to the m minus n. Here I have 4 to the 6 minus 2, which gives me 4 to the 4th. In this example, I have k to the 7 minus 13. That gives me k to the negative 5. Now, we don't like, negative 6. Now, we don't like negative exponents. So what we're going to have to do is put that in the denominator of a fraction. What about here? I know we could be tempted to move this to the denominator, but real quick, let's use to the numerator, let's use our exponent rules. So I have 3 to the 8 minus negative 5. Well, two negatives make a positive. So I have 3 to the 8 plus 5, which is 3 to the 13th. And we would have gotten the same answer if we'd flipped this to the numerator, because then they'd be multiplied together and we'd have to add their exponents. The power rule says that if a is any real number raised to an exponent, and I have another exponent on the outside of these parentheses, what I do is I multiply them together. Now, why does this work? Let's say I had 3 squared cubed. Well, when I cube something, that's asking me to multiply it by itself 3 times. And when I multiply exponents, I go ahead and I add them. So that gives me 3 to the 6th. See, I just could have multiplied them together and simplified my steps. So this would give me a to the mn. Here I would need to distribute because both of these have an exponent of 1. So I'd have a to the m, b to the m. For this third example here, I'm going to distribute to my numerator and my denominator. If I have x to the 4th to the 7th, that becomes x to the 28th. If I have 3x to the 5th squared, remember I need to square that 3, and that x to the 5th becomes 5 times 2, which is 10. You can go ahead and leave it as 3 squared, or you can change that to 9. They're equivalent, so it's totally up to you. Next, I have a to the negative n over b to the negative n. That gives me a negative n, b negative n. Do we like negative exponents? No, so we're going to have to flip this. So when an exponential expression is simplified, each base occurs only once. There are no parentheses, there are no powers raised to powers, and no negative or zero exponents occur.